In this chapter, we're going to be solving equations that have two variables in it. Because there are two variables, that means when I give a solution to this equation, I need to give two values, a value for x and a value for y. For example, in this equation, I would give the solution as 2, 4. If x takes on the value of 2 and y takes on the value of 4, the equation works because 2 plus 4 equals 6. But there are many other solutions to this equation. For example, 1, 5, negative 3, 9. I can even go into fractions or decimals, a half plus 5 1/2, 0.01 and 5.99. All of these are good examples of solutions to this equation, but how can I describe them all? To describe all of the solutions to a two-variable equation, I can draw a graph, and within this graph will be all of the different solutions, the positives, the negatives, the fractions, and the decimals, every single ordered pair, x and y, that work. Even though we can't list them all, we can look at them all on the graph. Each point that is on the graph and connected to another point on the graph will be a solution to the equation. Here's the graph of all the solutions to the equation x minus y equals negative 1. If we notice, this graph is a line. Not all graphs that we're going to see in this chapter are lines, but this is an example of one. There are also arrows at the end of this line that mean to us that this graph really does go on. The picture continues, but this is just the little zoom, in part that we can see. So the question is 1, 2 a solution to this equation? And there's two ways I can find this out. I can either look on the graph and see if the point 1, 2 is on the graph, which in this case it is, or I could plug that point into the equation. If I plug the point into the equation, I plug in 1 for x minus 2 for y, and I ask myself if this is a true statement. Since 1 minus 2 equals negative 1, yes it is. It's both on the graph and works in the equation. The next question is, does 3, 1 work? Or is 3, 1 a solution to this equation? Well, the point 3, 1 is right here. That's not on the graph. If I plug in 3, 1 into the equation, I get a statement that is absolutely not true. So that is my other way of proving that this is not a solution to the equation. Here's another graph to the equation y equals x squared plus 2. This graph will also keep going on if we were to extend the coordinate plane, but this is the picture that we can see now. Is 2, 0 a solution to this equation? Well, if I plug 2 in for x and 0 for y, I'm going to get a statement that 0 equals 6. That doesn't make sense. If I graph the point 2, 0, that's right here. That's not on the graph. Is negative 2, 6 a solution? Well, if I plug 6 in for y and negative 2 for x, negative 2 squared is 4, 4 plus 2 is 6. This works. The point negative 2, 1, 2, 6, 1, 2, 3, 4, 5, 6 is right here on the graph. Here's the graph of a much more complicated equation. While I don't have the equation, I can still determine if these points are solutions by checking to see if they're on the graph. The point 2, 0, 1, 2, 0 is right here. It's on the graph. So I'm going to say yes. The point 1, 3, 1, 1, 2, 3 is not on the graph. So it is not a solution to the equation. The point negative 2, 2 is right here. That point is also on the graph. The other skill we're asked to do in this section is to be able to graph an equation. We're going to graph an equation by creating a table of values. So our first step is to look at the given equation and create a bunch of xy pairs that we know work in that equation. Then we're going to graph those values. And from those points, we're going to determine what the shape of the graph is. So I'm going to start. 0 seems to be a good idea to start with x. You can pick any numbers you want to plug into. 0 seems like a good one to start with. So if x is 0, 3 times 0 minus 2 times what is 12. And I may need to do a little bit of work in order to figure out what y is. But basically I have 0 minus 2y equals 12, so negative 2y equals 12. Y is the value negative 6. So the point 0, 1, 2, 3, 4, 5, 6 is on the graph. I'm going to collect some more points. After plugging in 0, I tried 1, 2, and just for fun some negative number, so I tried negative 2, and I got these points that fall on the graph of this equation. It appears that all of these points fall in a nice straight line. If I wasn't sure if this was a line, I'd probably try a few more points. Maybe something like 4 or 5 for x. Plug in some more points. But this is good enough for me to say, this is a line. I'm going to connect it with a straight line and say that this represents the graph of the equation. Let's try another one. I want to graph the equation y equals half x squared minus 3. Again, a good number to pick right away is 0 for x. So let's plug in 0. Well, y I don't know yet, but 1 half times 0 squared minus 3. 0 squared is 0, times 1 half is still 0, so y must equal negative 3. The point 0, negative 3 is on my graph. I'm going to do this for a few more values for x. Yikes! I tried 1, 2, and negative 3 for x, and when I graph these points, it doesn't seem to really fit any sort of pattern. I'm going to need to try a lot more points before I can really see the picture of this graph. After trying more points, I'm starting to see a picture with this graph. It seems like it's U-shaped and would continue going up this way and up this way. It also seems kind of symmetrical, that whatever I got for 2, I also got for negative 2. So that's very interesting. I feel pretty confident that I can draw a shape for my graph, and it's not a straight line. I'm going to draw it in as curved and continue the arrows upward. If you're not sure about the shape of your graph yet, keep plugging in points until it becomes much more clear. I had to plug in a lot of points for this example to see.